Hey everyone, this is Nick Dearbertis teaching you financial modeling. Today we're going to be solving the lab exercise on generating and visualizing random continuous numbers in Excel. So this is the lab exercise, the first one in the internal randomness section. Um, and this is focusing on Excel first. We're going to complete the same exercise for Python in the following video. So the exercise, just to quickly recap on it, we're generating, for doing the whole exercise for 10,000 different numbers. We're going to generate the random numbers between 0 and 1, uniform. We're going to generate from a normal distribution as well. We're going to visualize those with a histogram, calculate the mean and standard deviation of each of those sets of numbers, and recalculate it and see how much things change. Um, so we're going to first need to generate those 10 random numbers of uniform and continuous. So we can uniform and continuous, sorry, uniform and normal. And so uniform, we just want it to be between 0 and 1. So all we have to do for that in Excel is the rand function. Um, and let's see. Here I'm also just going to put a counter for how many numbers we have. Then here it's going to be the normal inverse function of rand, and then 0.5 mean. What did it say? 0.5 mean and 10 standard deviation. Um, and as is always the good idea in a model, I'm going to make those actually inputs, the mean and standard deviation, 0.5 and 10, so that those can be referenced from there. And we could update that if we wish. And I'm going to fix those so that as we drag it, it's going to keep that reference. So then dragging this down, so we get 10 random numbers there of each type. And then the next step is to visualize those with a histogram. So first I'll go for the normal distribution. And we can go to all charts to get a histogram. Hit OK. We're going to want to um, modify the options for this um, because we want to change the number of um, different bins that we have in the histogram. So that let's see, is, I think, oh, maybe format the axis. Is that? Yep. So formatting the axis is how you get to these options for the histogram in Excel. So there we can set a number of bins. I'm going to say 10 bins and hit enter. And now we can see this is uniform n equals 10. And then I can go ahead and do the same with the histogram as well. Insert chart, go to the histogram. I'm going to move that down so that we can get both of them in here. And here, again, going to format that axis with number of bins. Let's again do 10 bins. You want to pick a number of bins that makes sense for your data. Let me do actually 20 here to get a little bit smoother representation. Now, of course, there are only 10 data points and 20 bins, so we have a lot of empty bins here. And then the other thing we want to do is we want to calculate the mean and the standard deviation of the generated numbers. So that's average. For the mean, we're going to average this range of numbers. And then for the standard deviation, scdev.s, it's a sample um, of that same range of numbers. And then I can drag that over to get that for the normal distribution as well. And I'm actually going to move this over to here just because later we're going to expand this to 1,000 observations going down over there. So now the exercise says we want to recalculate this thing a few times. So you can see as we recalculate it, the distributions look very different each time that you run this. And the means and standard deviations that we see also similarly jump around quite a bit. So now this is our n equals 10 sheet. Now we can copy this sheet. Of course, this is an advantage of the way you have to go about this in Excel. Disadvantage, because if we wanted to make any more changes to this, it would require re-going through this copy sheet process and redoing this. But now I'm going to take this down to 1,000 observations of drawing from these distributions. So I'll cut it off at 1,000 here and go back up. And now we can adjust the ranges of these charts as well. So can drag it all the way to the bottom. There's only 1,000, so it's not too bad to do that. You can also go into the options and manually edit the range. Just change it to be 1004 for the end. So I've done that. And now we can see it actually with 1,000, it does look fairly uniform. It's all the bars here are fairly even. Now let's make this change over here. So for here, I'm going to go into select data for the other approach that I mentioned. I think I said that 1,004 was our last row there. So I'm just going to manually edit it like that. And you'll see that allows it to pick up all the data. So there, now we're seeing something that looks like a normal distribution come up from the histogram. In contrast to n equals 10, it's very hard to discern what distribution is going on here. I'm going to also expand these to 1,004 by manually editing the range. And then drag these over. And then what you can see with the mean and standard deviation, now as we recalculate it, it's going to be quite a bit more consistent. That the mean of the normal distribution is usually not going to be too different from 0.5. It does move around that, but not very different. The mean of the uniform is always coming up near 0.5, and the standard deviation of the normal distribution is coming up towards 10 every time. Whereas in the n equals 10 case, these numbers are jumping around quite a bit more. So that is the difference that the number of observations makes. Your estimates get a lot more consistent and closer to the actuals. So as we expand into doing more stuff with randomness, keep in mind that the number of iterations is a very important factor in determining the results that you're going to get from your model. So that's the exercise in Excel. We'll come back next time to complete this exercise in Python. So thanks for listening and see you next time.